Very warm welcome to all of you once again the C programming video tutorial presented by Professor Rakesh Ishwangedam. Our today's agenda is try to understand what are the different programming structure, that is sequence, selection, iteration and modular. So we let's begin with the programming structure. As we know that computer is nothing but a machine, and every machine can understand some instruction which is going to produce to perform some particular task. So those instruction or a statement is used to inform our computer to perform some sort of activity when program is in executed. The statement that are used to control the flow of sequence of program known as control structure. So we can say that control structure is nothing but a mechanism which control the overall flow of execution of our program. So based on the order of execution of a statement, the various control statement has been classified. Those control statement are broadly classified in four main category. Those are nothing but sequence, selection or a branching statement, then looping statement, and fourth one is a modular approach. So let's we check one by one in detail. In sequential statement, the programmer write a sequence of a statement to do a specific task. All these statements in a program are executed in a order in which they appear in the program. Those program statements are executed sequentially, that is one after another, called as sequential control structure. Hence, no separate statement are here required to make this statement executed in sequence. In flowchart, the sequence of a statement are usually contained using the rectangular process box. So, we may summarize a sequential statement or sequential control statement in a very brief scenario, that is sequential statement are nothing but a way which are executed one after another in a linear fashion, and due to of this its linear fashion there is no separate statement are required to execute a statement in sequential order. So here we demonstrate a small snippet for a program converting degree in Fahrenheit. So as we know that to convert Fahrenheit to degree, we have very simple formula, that is C is equal to 5 divided by 9 and whatever the value of Fahrenheit which is subtracted by 32. So how this formula or how this conversion can be written in term of sequential control structure. So we followed some prescribed step, that is input the degree in Fahrenheit because we want to convert from Fahrenheit to degree. Compute Celsius, C is equal to 5 divided by 9 and F minus 32. Here F is nothing but the data or input we capture from the user as a Fahrenheit and display the result which is going to stored on C, and we will going to stop our execution. The advantage of sequential control structure is that no separate control statement are required to execute the sequential of statement to reach one after another because it is already in the sequential manner. Obviously, it is in a sequential manner so that it is easy to debug. The biggest disadvantage of a sequential control structure is that the statement are executed in a linear fashion or sequential fashion, hence we cannot change or we cannot alter its execution. So we can say that our sequential control structure is nothing but a way in which we can execute the statement one after another, and having advantages that easy to debug, and drawback is considered as we cannot alter the sequence of a statement. So we will go into depth and try to understand what is the second kind of control structure, say branching statement. So the branching statement or branching control statement are nothing but those kind of statement that alter the sequence of execution of program. Means in the previous sequential control structure, the drawback is that we cannot alter the sequence of a statement, but suppose we are in a situation we want to alter the sequence of a statement, then there is a mechanism to us that is called branching statement. Is we know that in a sequential control structure, we cannot alter the execution order which is already in a sequential. However, computer can skip the execution of some statement, and this skipping facility is provided us by mean of branching statement methodology. Then our branching statement can be classified in two broad category. That is, one is conditional branching statement and second is unconditional branching statement. The conditional branching statement are nothing but simple if else statement, next if statement, else if statement. Whereas our unconditional branching statement are went into category of go to, continue and break. Here is an example of simple if statement. When the set of statement have to be executed or skipped when condition is true or false, then we will go for if statement. The simple syntax of if statement is that if, then we provide the condition, and if it is condition is true, then the set of statement from 1 to n has been executed in the sequential order. Here is program to demonstrate whether the given number is even or odd based on the branching statement, say if branching statement. So first of all, we need to import some directives, say iostim stdio.h, iostim conio.h. Then we pass the control to the main function, and then we take one integer, say n, which have the integer type. Then we are going here to print, enter the value of n, which is asking from the user. Then by using the scanf function, we'll scan the value by using n. And here is actual logic. If n modulus 2 equal 0 means value of n whatever maybe, if we provide the value of n is equal to 10, so 10 modulus 2 means 10 divided by 2 gives 0. It means that the particular number is even. Whereas if we consider the value of n is equal to 7, so 7 modulus 2, that is remainder is 1, means if our here our condition is false, mean we the particular number is not even. Next we check if else statement. If else statement is a simple selection or a decision statement. It is a two-way decision statement which executed one after another, or a block of statement are executed in a sequential manner. If the particular condition is true, one of the two-way decision statement is done when the condition is true, and another one when the condition is false. I mean to say that, suppose if there is a condition true, then if block is executed, and when the condition is false, then the else block is executed. In a syntax, we can analyze if here is a condition provided, condition whether true, then statement A is executed. So if the condition is false, means our control went to the else statement, and statement 2 is going to execute it. Let's we check by using the simple program for testing whether the particular number is odd or even. Here the logic is almost same from the previous program. Here we also take the stdio.h, which is the standard input output directive. Then we kept to conio.h for display the result on a console. Then control went to the main function. Inside the main we declare variable n. Then printf enter the value of n, which is asking from the user. Through the scanf function we can read the value, and here is actually logic for if else statement. We check whether the if n modulus 2 equal to 0. If n modulus 2 is equal to 0, then control pass, then this particular statement number is even is going to print. Otherwise control went to the else statement. When if condition is false, then control went to the else statement, and number is odd is going to print. Here we take the example. If value of n is equal to 10, then here we accept the value of n from the scanf function. Then 10 modulus 2 means here we are finding the remainder. So 10 modulus 2 means 10 divided by 2 gives remainder 0, means this statement is going to print that is number is even. Whereas consider the second example where n is equal to 7. When n is equal to 7, this logic is going to evaluate it, and n is modulus 2 gives remainder 1s, which is false. for this particular block, hence control went to the else statement, and hence number odd is p1, number odd is print, as we know that the number 7 is odd. This is a simple demonstration of if else statement. Let's we further check what is a nested if or multi-way decision statement. All the if or if else statement within the another or if else statement are called nested if. Means all if or if else statement within the another if or if else statement. Means inside of if or else if we were keep another if else statement, then it is known as nested if. Nested means inside of if or inside of else. If we are able to keep some another statement, then it is known as nested if. nested if मतलब एक if के अंदर दूसरा if या एक else के अंदर दूसरा if. So hence it is called as a multi-way decision statement. Here is a syntax of how to write the nested if statement. Here we first of all give the if condition 1. If this condition is true, so inside the first if statement we will write the another if condition for condition 2, and if this condition 2 is evaluated true, then statement A is going to evaluated or print, otherwise else statement of A2 is going to print. Similarly, in an else statement, we will again keep some condition 3, and if this condition 3 is evaluated true, then statement B1 is going to execute it. Otherwise, else statement of inside else statement is going to execute it. This is called if inside if or if inside else. Hence, it is called as a multi-way decision statement. Let's check advantages of it. There is a situation involved the series of decision where we forced to use the if or else if statement in another if or else statement. In situation, nested if statement are used. Each and every condition may be evaluated to true or false or may involve the expression the various data type. In that scenario, we can use the if nested if statement. The disadvantage is that the depth of nested is increases. As we see that in the previous syntax, the depth of nexting or nested if is increased, hence readability of program is decreased. It is difficult to understand and it is difficult to modify due to inside one if there are several if or inside else there are several if statement can available. Here we take a simple example. Using through we can try to understand what exactly or how exactly nested if statement is work. So here I demonstrate a simple algorithm. Say in step 1, I'll read the value of A, B and C. Step 2, I determined which one is the largest among of 3. So in first if I am going to check whether A is greater than B. Yep, if this particular statement, first if statement is going to true, then I am going to check if A is greater than C. If both statements are true, then write A, means statement A is going to print. Or if the first if statement is true, means A is greater than B, but second if statement, that is A greater than B, C is false, then the right C statement, means else statement, going to evaluate it. Similarly, in else statement we are going to check a first if else statement. If B is greater than C, then we are write B, else we write C. So in this way, inside the one if we can put the several if statement, hence our readability of program is decreases, and sometimes the understandability can be difficult for the new programmer or a new coder. So further we check the else if ladder. What exactly else if ladder is that? This is the type of nesting in which there is if else statement and every else part except the last else. Means inside the every if statement there is a else statement. This is type of nesting often used in the program, is called also called as else if ladder. Here after seeing the particular demonstration, might you have a bit clear idea. In first if condition is true, then statement A is evaluated. Again we give the else if condition. If this condition is false, then we are testing for else if test else if condition. Again we are check further else if condition. If it is true, we are going to print the else statement, statement C. And if all these statements are going to false, then we are going to print the else statement. Means inside of if we are putting several else if statement except the else statement. This kind of mechanism known as else if ladder. Means we are putting if statement, and inside if statement we are giving some else if statement. The advantages of that else if ladder is that the expression of various data types such as integer, character, float, double easily handled by simple calculation program like that. And disadvantage is that it is hard to understand and modify, as we all know that after observing the situation of this particular syntax. Then there is a depth of nexting is increases, and obviously that's why the readability of program maybe decreases. So till now we try to understand what exactly a conditional branching statement. Now our next motto is to try to focus on what are the unconditional branching statement. Or unconditional branching statement are nothing but those kind of statement which allow us to skip some sort of execution or a statement from the set of instruction, and this category comes under either go to, break or continue. So go to, break and continue, go to, break and continue known as unconditional branching statement. So let's we check first of all the go to. It transfer the flow of control to another part of program. When I want to skip some part of portion and want to concentrate the another part of program execution, then I go for go to. So here is syntax: go to label 1, then set up a statement, and here in label I give the some statement. Here label is the any valid C identifier and followed by semicolon. Here is a small snippet which is again the check whether the number is odd or even. I am taking same example due to because you may concentrate or correlate how same program may written in a different way depending upon your logic or skill set, so that you better understood we have n number of solution to write the same code or a same objective by mean of different programming methodology, either by the conditional statement or unconditional statement. So here we check in a main function. I'll read the number n and ask to enter the number. By using the scanf function, I'll read the number n and check whether n is modulus 2, means the remainder is 0 or not. If it is 0, then reach to the even, and if the remainder is not 0, then I label is to and forced to print odd. So what happened when control went to the even? When control went to the go to statement even, then the inside the even I write the printf even number is given number is even is going to print, and here my go to statement is end. Similarly, when number is odd, so control went to the odd statement, and for odd I write the number is odd, and here I make the go to statement again end. So after saying that, we can observe, suppose here my n is 7 modulus 2. Here is my evaluating condition. If n is equal to 7 modulus 2, means I will get the remainder 1. Means in go to, obviously it is going to switch on odd. So control go to odd, and what exactly written inside odd, my compiler is going to check from over to here, and in this statement I'll observe what is written. The statement print number is odd is evaluated. Similarly, we will check the break. Break statement is used to inside the loop and switch statement. Sometimes it is necessary to come out from the loop even before the loop become false. In such situation, break statement is used to terminate from the loop. This statement cause the immediate exit from the loop in which this statement are appear. Here is again example to print some statement by using the for loop. Here I give the control to the main. Here I read the number n, And inside for loop I write n is equal to 1, I less than equal to 5, and I plus plus I is increases by 1, and it is check up till value of I is less than or equal to 5. And if condition here is mentioned, if n is equal to 3, means first time n is equal to 1, when I am going to increase value of I by 1 by I plus plus. Next time I become 2, again I increase the value of I by 1, means n become 3, and when n become 3, printf, I understand the use of break, and here I break this statement, means as and when we get the value of n is equal to 3, I am come out from the loop. So print number n is here, and we will reach outside of the loop. This is nothing but a simple way when we want to the exit from the loop, even the termination condition reach. Here our termination condition is nothing but n is equal to 5. But before you want to reach 5, I want to move switch out from our particular loop. That's why we will come for break statement. Next, we will check out the continuous statement. The continuous statement used when we want to go to the next iteration of the loop after skipping some sort of a statement. Continuous statement can be written generally when use some condition. When continuous statement is encounter, all other remaining statement, that is statement after continue, is current in the current iteration are not executed, and loop continue will the next iteration. If you have the any confusion after observing this particular code snippet, might your idea may be clear. Or control went to the main function. As we know that main is nothing but a function from where execution is begun. Inside n, I am going to check n is equal to 1, n less than equal to 5, means it's our termination condition, and I is equal to 5. In same case, I'll try to check up to the value of n is equal to 3, means first time n is equal to 1, again I increase n by 1, so n become 2, again I increase n is equal to 1, so n become 3. And when n is equal to 3 and n less than equal to 5, which is not our termination condition, so we got n equal to 3. So here is print, I understand the use of continue, and I'll continue. So printf number is continue, and we will reach to outside of the loop. In this way, we can understand the use of or different control structures, say go to, break, and continue. Here is a big difference between break and continue. When break is encountered, loop is terminated and control transfer to the next statement following the loop. But when continue statement is encountered, loop is not terminated and control is transferred to the beginning of the loop. I hope you understood. Our third sort of control structure is nothing but a loop or repetition. The statement that enabled the programmer to execute the set of statement repeatedly till the required activity is completed is called looping or iterative statement, or simply loop. The statement within the loop may be executed for fixed number of time or until a certain condition is reached. This scenario known as repetition or looping. The various kind of looping structure that are supported by the C programming are not only C programming. We will utilize this looping condition in the upcoming programming language like C++, Java, COBOL, Fortran even though. So we check one by one. So first of all, we check the for statement. So the for statement, we may say like that, the setup statement may have repeatedly executed for the specific number of time. In this situation, we use the for loop. The for loop is defined as a iterative statement that causes a set of statement to be executed repeatedly for the fixed number of time. If we know well how many times the set of statement have to be executed repeatedly, then a for loop is our best choice. Here is the syntax of for loop. For, here's the expression 1, expression 2, and expression 3. Then inside the for loop, we will going to print some statement 1 and statement 2. So I request all of you, you must try to understand what inside the expression 1, expression 2, and expression 3. Here for is nothing but our syntax. Inside for we give the expression 1, expression 2 and expression 3. Here expression 1 is nothing but our initialization condition. In the previous example we check I is equal to 1 or I is equal to 0. So here expression 1 is nothing but our initialization condition. Our expression 2 is nothing but our test expression, is our what we call the termination condition. When the termination condition is reached, our control went outside. And 3 is nothing, expression 3 is belongs to our increment or decrement operator. Let's check for loop by using some simple example. Here I would like to perform multiplication of two numbers without using the multiplication sign. The logic is very simple. When I add the next number in the previous number of a table, then I'll go get the multiplication. Suppose I want the multiplication table of a 2. So 2 twos are 4, means 2 is added to 2 and it will gives 4. Similarly 4 is added to 4, it will gives the multiplication of this particular number. Similarly I use here the variable a, b and I, and I am going to store result on variable 0. So we write the print, enter the number to the multiply. In scanf function I'll read the value of a and b, and inside for loop I'll check the value of I initially 1, I is less than equal to b means our second number, and I plus plus. And inside result we are going to print result plus a, means initially our result is 0, and whatever may be the value of a means first number is going to add it to my result, and then I am going to display the result. So in this way we can print a multiplication of any number without using the multiplication operator in C programming. Next we check the while loop. So our while loop is nothing but a set of statement may have to be repeatedly executed till the certain condition is reached. In situation we do not know exactly how many times the set of statement have to be repeated. In this particular scenario we'll go for while loop. Generally by while loop the statement are called test and do structure. Please try to understand the difference between while loop and do while loop, because both are almost similar. It's not exactly we can to say like that. We can perform the same task by mean of for loop, while loop, do while loop, but do while loop is used for test and do the structure, whereas or while loop, where do while loop is used to evaluate the executed once and then evaluate the condition. So we check the syntax. In while loop we'll give the condition, and if condition is true the set of statement 1 to up to n is going to print. By using the while loop I would like to print the number. So here I declare I is equal to 1 while I less than equal to 10, and inside while loop if this condition is true, so I'm going to print the value of I, and I give the I plus plus. If we compare our for loop with while loop, so here I is equal to 1 is nothing but our initialization condition, while I less than equal to 10 is nothing but our we can say termination condition, and I plus plus is nothing but our incremented or decrement operation operators, which is nothing but our updatation part. And if this condition is true, then I'll going to print the n. So in this way we can able to print the number from 1 to 10 using the while loop. Similarly we can check out about the do while loop. Do while loop is similar to a while loop and used when the set of statement may have the repeatedly executed until the certain condition is reached. When we have no idea about exactly how many times the set of statement have to be repeated, then we will go for do while statement. Here is the syntax. Here we give do statement, then opening the curly bracket, the set of statement 1 up to n number of statement will going to print, and then after curly braces we'll give the while condition and then terminate it by using the semicolon. Let's we check in detail by using the example. Very similar example to print 1 to 10 using do while loop here. So here I initialize I is equal to 1, which is my initialization condition, similar to my while loop, the for loop. Here I give the syntax do. Inside do I print the value of I. Here at least I is at least one time is going to print, and then I give I plus plus, which is nothing but my updatation operator, gives either incremented or decremented. Here I am interested to increment the value of I by 1, and I test the condition while I is less than or equal to 10. When the value of I is less than or equal to 10, till that time my loop is executed, and it will come out after the termination condition. So in this way we can demonstrate or differentiate between our conditional loop and our unconditional loop. Similarly, we check here our looping statements, either by for loop, while loop, and do while loop. Next, we check the foremost important structure, that is called modular approach. The approach of breaking down the original program into a several independent sub-program or a module and then executed this statement in the sequential order is called modular approach or modular technique. There are certain features which generally possessed by modular structure, that is modular design increase the programmer productivity. It allow them to look at the big program first and then focus on the latter on. The several programmer can work on a single program and large program, and each working on the different module may be possible by using the modular approach. Modular design for one program can reuse in another program required for the same task. Modular can be reusable, and relation between the modular shows the modular design of the program. Meaningfully, modular name identified the task performed by each individual programmer. So here we take the example, our big program can be broken down into small sub-modules, say module 1, module 2, up to module n. And when we integrate them, we'll get the desired result. The advantage of this approach is nothing but focus on the small component of a big program that can be easily manageable. Each module perform the definite function which is easy to manage, obviously, and subprogram may be have the solution shorter and reduce the bugs easily. Coding and testing, also the debugging of the individual small independent program is quite efficient and easier compared to the testing and debugging of the big program. And main module can be linked with the sub module to solve the main subprogram main program task. The task can be divided the many reusable subprogram. So by mean of this we can say that our big program divide into small subtasks, and these subtasks can be further proceed, arrange, or solve such a manner that each individual perform the specific task, and then each individual subtask can be integrated to our big problem to get our solution. There are certain disadvantages too. That is, any changes in the program will also affect the individual module of the program. Second important disadvantage is that the module design must be independently tested. A module must perform some specific task, and breaking because of linking of the module, the execution of the other program take the extra time. And I hope you people understood the concept of what we studied, and I hope you people enjoyed our video. So I would like to thank you very much for being with us.